Hello everyone, my name is Adrian. He's Abel, Freixas, and Andoni, Acosta, and with Team Larry, we're doing the hand pump filtration system. This is the outline. This is how we're gonna start with the problem statement. Then we're gonna do the literary survey, division of responsibility, survey of related standards, and then proposed design, and end with conclusion and future work. The problem is that 2,000 children are dying every day from drinking contaminated water. To put it in perspective, this is like 90 buses crashing every day full of the gardens with no survivors whatsoever. The issue is that they're drinking a lot of water with contaminated feces. This is because they do the necessities in urban environment and intend to contaminate the water source. In top of this, you have agricultural waste being dumped in the water source like herbicides and pesticides, and this leads to a lot of clogging in the quality of the water. As you can see, this is what is found in the water. These many bacteria, they lead to a lot of waterborne diseases, with the century leading the top chart. This is just a few, but there's too many to list. The thing with the century is that it dehydrates a lot of people, and you add this to a country that have issues with water supply, or it does is compound the issue. This is the worst killer for children in the world. Our solution, what we plan to design, we want to design a system that will contaminate 1 gallon per minute of water. It's going to retain a long product life. Does not require electricity to raise, and going to be in thermal conches, and able to store large amounts of water, and portable and inexpensive as possible. Leader survey. This is a survey that we did just for the call with 2007. The US and an organization that spent $5.5 million on help on water bottle. This is close to 6.5 million in today's market, and they were able just to target around 270,000 people. This is what other people have done to resolve this issue. This is the light straw. What they do is they use like a pen and they soak water through the pen and it purifies the water. We have another system with the pure water bottle where it does is it just purifies the water using UV light. And then we have the light sack and the solar power. The light sack we use gravitational in order to purify the water, and the solar all use sunlight. This system they take a lot of time to purify water, and it doesn't do large amounts of water.
This is the division of work. Adrian was in charge of research and putting together a presentation, and then Acosta was in charge of the calculation, and I myself was in charge of the designing of our system. These are some of the survey that we follow. These are the schematic of our design. So you can see we have a water storage tank, a bomb streaming, which is going to filter out any type of debris that might be happening to a pump. The pump itself is going to be drill. It's going to be a hand pump drill. It's going to be a hand drill pump with a gear system. Also, it's going to have a pressure gauge, carbon filter, and last, going to have the one gallon per minute flow restrictor in order in order for the not to damage any of the filters. And lastly, we're going to have our UV light that is going to remove any type of bacteria that might be left in the system. The UV light filter is going to be powered by a dynamo or an alternator, which is going to be incorporated in our unit system. For all the piping that we're going to use in our system, we're going to use copper piping, so it's FDA approved. It's very cheap to use compared to other material, and very easy to handle.
So basically, we use the Bernoulli equation to get the pressure head for the different components in our water loop, and also to get the power that the pump will need to provide the water with enough pressure and enough volumetric flow. After we did all the calculations, we came up with a 0.12 horsepower. That's the power that the pump will need to provide the water. Based on that power need that we had, we just found the Hydro 4001 series pump, which is an extremely compact pump weighing only 5 pounds, which will be beneficial to our system since it has to be relatively portable. And it has a 3.25 inch inlet diameter and outlet diameter. The pump basically comes in 3 materials. It comes in iron, Ni, and silver series. These 3 materials vary the cost of the pump overall, but as you can see in the table, it also varies the life expectancy of the pump. Being the silver, the most expensive, but it has 1,000+ hours of reliable usage. This is an schematic of the pump showing the simplicity of the pump. It has, as you can see, have a few moving parts, and as we engineers know, the less part we have, the less things that can go wrong in any system at any given time. From the performance chart of the pump, we needed the pump to work in this region from 75 psi to 100 psi, and then in order to achieve that amount of pressure and volumetric flow, we needed to provide around 0.3 horsepower. Now, how are we going to provide 0.3 horsepower to a pump? Is my next slide. We decided to go with a 2-stage compound gear train in order to provide a pump with enough RPMs. We use 4 gears, totaling to a 9-to-1 gear ratio. But at the same time, we also did an experiment with a torque range when each of us and our girlfriends, we measure like how much torque we could apply to a fixed bolt in order for us to find the comfortable torque that a human would be in. We found it to be 15 pound-force per feet, which putting in our gear system, we provide to 0.17 pounds-force per feet, which is enough to power our system. This is also the design that we did, incorporating the casing. As you can see the different parts that we have in the gear train. We designed a casing because we are planning on filling the gears with oil in order to extend the life of the gear system and to reduce friction losses due to heat.
We're going to be talking about carbon filters. What does carbon filter remove? Carbon filter remove most of the microorganism of the pesticides, herbicides, also E. coli, which is very dangerous. There's basically two types of carbon filters in the market. One is the granular activated carbon and low carbon. The difference between both is the way that they are manufactured. The granular activated has a coffee ground consistency, and this one is more of a block. This one is going to be for a system we'll be using this one, so it has a longer life. What doesn't remove is a small particles between 40 to 400 nanometers in size. Since carbon filter doesn't remove that, we're going to be implementing an UV light system, filtration system in our design. Since the way that the UV light works is that it penetrates the walls of the microorganism, changes the DNA, making it then impossible for to reproduce. The advantages of UV light is that it's chemical free, auto Tesla free, is compact and easy to maintain. The minimum required for the UV light to work is 60,000 microwatts per second per centimeter cubic. The bulb that we're going to be using in our system is double that, is 3,000. This is a chart showing the different type of bacteria and the amount of time that it will take using this bulb in order to kill them. The biggest, the one that has the most amount of time is this one over here. This one is 0.64.
So to conclude our presentation, with the reason why we did our project is to have a solution for a problem that's been existing for a few years. Not only that, with our purification system, non-profit organizations and governments, we have we have a higher initial investment, but it will last more time than the current solutions that they have. Also, for future work, we have pending simulation and testing of the system overall, the design and implementation of the dynamo that we want to implement in order to power the UV light. We also need to design and manufacture the packaging and manufacture all the different components altogether. Any questions? Yes, sir.
So you mentioned that you wanted to fill your gear system with oil to reduce friction. Will the gear be separate from the rest of the machine to avoid any contamination?
Yes, of course. The pump per se has a gasket that protects from the environment. That's what's going to keep the oil contained in the water.
Okay.
So because this is going to be, the gasket is going to be in here, and the gas is going to be in here. This is going to be the pump that we're going to be using.
How often do you have to change the carbon?
The carbon, the carbon is dependent on the manufacturer of the filter, but it's around 20,000 gallons of water.
The only thing that keeps our system, the part that keeps the system, give the short cycle system is the pump per se. That's depending on the amount of the pump that you choose. If you go to the cheaper route, which costs around $90, it lasts 130 hours. But just 130 hours, it equals to almost 80,000 gallons per use. And if you have a person that drinks half a gallon per day, divide that by the amount, it's going to give us 16,000 days for just one person. That equals almost to 40 years. I mean, if then you add to this a whole family, which equal to 4, it goes down from 40 years to 10 years. You add 8 people, it goes to 5 years. You add more people, it keeps down the life of the pump. But we could put the pump to at least 3 to 5 years with 8 people using it. But if you want to go with the higher-end pump, which is around 1,000 hours of use, I mean, you will have it for as long as the UV light works and the carbon filter works.
Okay. Are all the components I'm looking at there designed by your group?
Yes. This one?
Yes.
Yeah.
Well, we are designing the casing and the shaft. We are on the handle. We are buying the gears.
The gears and the
gears.
pump?
The pump, we're
And the
integrating
pump,
the
yes.
system.
Yeah, the pump, the way that the pump's going to work, let me go back to the schematic of the pump. Where was the? Okay, the way that we're gonna repurchase this pump, and we're gonna take this part out and custom fit it. Or this pump is gonna be custom fitted to the back of the casing. That's basically what we're gonna be doing. Instead of incorporating the whole pump design, we're gonna take this out and incorporate this.
Okay, so talk to me about the design phase. Simulations, modeling, are you doing any?
Yeah, we still haven't got to that level, but we're gonna do flow simulation. We're gonna do go back to
A stress simulation
Stress simulation.
on the gears,
On the
on
case.
the shafts.
and something we go back to the one of the reasons that we did go back. Go, keep going. Go back. Go back. One of the reasons we decided to do the front of the housing made out of ABS. One of the things that we did is create rivet because we wanted to last as much as possible. Because you have a lot of force going through the handle, so we're going to make sure that the cover is going to hold. We're first going to try with ABS. If it doesn't hold, then we're going to have to change with cast iron. That's ABS costs a lot less to do to manufacture.
The back part should be made of the prototype is going to be made of CNC aluminum. If it goes into production, has aluminum, which is a lot cheaper.
Okay, and walk me through the testing. What do you plan to do in the way of testing?
We're going to run we're gonna find the dirtiest water possible, we're gonna run it through the system, then we're gonna take it to a lab to have it tested. We're first gonna test the water to see what kind of particles they have. We're gonna see if the system is able to take them out. Then we're gonna take
Okay, so that's telling me how good the filters and the microbe system is. What are you doing in the way of testing to tell me how good the pump that you've designed?
First, we're going to put a flow meter after the pump to see actually with experimental data how much volumetric flow is going after it's flowing out of the pump. If it's a value that we feel comfortable with, or if it fluctuates above the 1 gallon per minute that we require for the filters to work properly and the UV light, we put a restrainer after the flow meter to keep the water flow to 1 gallon per minute. After we feel comfortable with our system that it works properly, we're going to then test the water to see if the filtration system purifies and takes out all the bacteria.
And to add to what I say, we're also going to add a pressure meter to the pump because the filters and the UV light need to have a certain pressure. That's why we're using the pump.
Thank you.
So, building off his question, how are you going to test the gear system? How many times you can wind it until the system fails?
The way that our plan was to use a drill. You know, the drill has different speed. It goes for 1,000, 2,000, and 2,000, and then just use the drill to get the pump to run at its maximum RPM to see how much does it last, or the kind of pressure that it has, and how long does the gear last. Running the system at least from 1,000 RPM to 2,000, because the maximum RPM of the pump is 1,800. So
It's
You have to be careful because if you're running it at max speed, your pump is gonna.
it's gonna be out of the efficiency table. So.
It's actually, the pump is ready to run to 1,800 RPMs. We plan on running it to 900 RPMs, which is way below its maximum. Also, the gears, we can do the experimental analysis on the life expectancy of the gears, but gears nowadays are built really tough, and we don't think that will be the case, the failure of the whole system. And we're going to buy it out of a manufacturer. We're going to buy a medium quality gear at the same time. So gears is not our main concern. But of course, thinking about, we are going to implement the oil just in case to increase the life expectancy of it.
Right, I'm not concerned about your gears, I'm concerned about your handle, right?
The handle.
You have someone using that, maybe
Yes.
pumping faster or slower than they're supposed to, and at what point does that handle break off, or your casing, or any part of your machine, right? You're testing your flow rate, that's great. You're seeing how your water, or the condition of your water, that's also a great test. But if your handle or your pump or the casing isn't working, the rest of the system fails.
The idea would be to have the handle made of one piece, and then what we would do is the handle dipping on plastic tip. It's just one piece. There's gonna be less parts to it, so that's gonna add to the life of the handle. The other thing that we could do is go with better materials, but that's gonna add cost, and it's gonna be the life of the handle is gonna be the way that's gonna be manufactured. That's the main thing.
What kind of temperatures do you expect when during your testing? What kind of temperatures are you expecting inside your case?
The maximum amount of temperature that we can have is 140 Fahrenheit. Over that, it's gonna be in favor of the pump. So we're gonna do the testing and see how much the temperature increase. We have oil, so that's gonna increase some temperature in the casing. So it's not gonna add much temperature to the water. But I don't think it's gonna go over 140.
And what temperature will your oil? Do you have any idea of what temperature your oil will start breaking down?
We plan to using for now a conventional standard oil that I use on cars, and they last until 250.
I'm sorry to bother you.
Yeah, go ahead.
We were just discussing, if your pump requires 900 RPM to function properly, you have to spin the handle 100 times a minute. Have you seen if you're actually capable of spinning that?
That's how we
retain
came
that
to
for
a
a
number,
minute?
because we tested how many a person would do 1 minute. So that's how we came to 100.
But you've tested
Yeah,
that
we
with
went
the
to the-
resistance of the water, right? Because it's different when you're doing it with air than when you're adding the
Yeah, definitely. I mean, you will go into, that will be the testing. If it doesn't work like that, if instead of 100, say it's too high, 50, then we're gonna have to go back and change the gearing system.
But instead of doing that, think of it before, right? Think of it now, and see, and have something lined up already
Yeah,
where
good point.
if you go to 18:1 gear ratio, you already have a design where 4 months from now, you don't have to go back to the first step.
We're gonna have to think away how doing that with water instead of air, because I mean, water you're gonna have more friction than air. That's true, man. Probably it's gonna, now thinking about it, probably it's gonna be less than 100, it's gonna go 50 to 7.
Try it.
Yeah.
Try doing that for a minute.
Yeah.
Could you talk more about the economics of all this?
We want the pump to be as inexpensive as possible. We're trying to reach the target from 500 to $1,000. The price is going to depend on the life of the system. With the system having a bigger life, it's going to cost more. But that's something they're going to have to pay with. So yeah. But I mean, we have people spending 5.5 million just to target 270,000 people. I mean, our system is going to target more people and going to look a lot longer than just